Hi guys, so now let's go and solve these problems. So here now I have the electric field and the area, the first question, area is perpendicular. So the angle between the electric field vector and the area vector is 0, right? So electric field and area, the surface is perpendicular, so angle between them is 0. So my delta phi would be nothing but E dot ds into cos of 0, right? So this would be 10 into area, which is 10 centimeter square. So I'll just convert into meter square. So what is 10 centimeter square? So this would be 10 into, and 1 centimeter is how much? It is 0.1 meter, right? 1 centimeter is, 0.01 meter, right? So this would be 0.001 meter whole square, right? So this would be 100 into, and this would be 10 to the minus 4, 10 to the power minus 4, and this would be equal to 10 to the power minus 2, right? 10 to the minus 2, and what would be the unit? The unit would be volt per meter into meter square, so that would be voltmeter, right? So this is going to be my my electric flux here in this case. In the second case, it's now the angle between the electric field vector and the area vector is 45 degrees. So now straightforward. So here my delta phi is going to be, or the flux is going to be E dot delta S, which is 10, right? 10 into 10 to the minus 4, right? 10 into 10 to the power minus 4. Right? This is in meter square. And this into cos 45. Cos 45 is cos 45, which is nothing but 1 by under root 2. So this would be 100, so this would be 0.01, right, upon under root 2 voltmeter. This is my electric flux here in second case. Now this case, this involves a little bit of creative thinking, right? So here you must be thinking, okay, here I gave you a flat surface, right, but here it's a curved surface, right? So that kind of makes it, so how do we think about this, right? Now if you, I told you that the electric field is uniform, right? So if you visualize in terms of electric field lines, the number of lines crossing this area, if I take this, the top of the hemisphere, think of a hemispherical bowl, take the top, what would the top be? Top would be a sphere, and it would be a circle, and its radius is going to be same as r. So number of field lines crossing this surface, right, is same as number of field lines crossing the hemispherical surface, correct? Electric flux is what? It's nothing but the number of field lines crossing the surface, right? So which means electric field lines for this surface would be same as for this surface, right? Now for this flat circular surface, it's very, very easy. Why? Because now here the surface, again back to the same question. It's like this. So here we have, for this surface, delta phi would be electric field, which is 50 into area. What is area here? Pi r square. So would be this into 3.14 into r square. What is radius? Radius given as 10 centimeters. So this would be 10 into, now I'll again convert it into meters. So 10 into 10 to the power or 0.01, right? So this is this square, correct? Now here I've not written the units, so I'll just skip the units also. I'll just add in the end, right? Need not mention. So now fairly simple. So now this would be what? This would be, so this is going to become 0.1. 0.1 square would be 0.01. So this would be 50 into 3.14 into 0.01. And that would be nothing but, it would be 0.5 into 3.14, and that would be so 14, 5, 70, 5, 3 is a 15, right? Let me just make sure I don't get the maths wrong, right? 5, 70, 5 is a 15, and 3 decimals, so 0.157, right? Sorry, 1.57. My apologies, 1.57. 1.57. So now my delta phi is equal to 1.57 voltmeter, right? This is the answer. Right? So this is the way, this is the way to think about electric flux. And in the next video now we'll start further progressing towards the derivation of Gauss's law. Thank you.